Melissa was one of the strongest storms on record.
New York City flash floods turn deadly after rapid downpour.
After intense flooding, Barcelona is still battling drought.
Our planet's climate, it's breaking its own rules. Floods where there should be droughts. Pakistan record monsoons. Droughts where there should be rain. East Africa, southern Spain. Even scientists can't explain why their models keep missing what's next. So what changed? Scientists went back hundreds of millions of years to find out, and they discovered something unsettling. This has happened before, and not once, at least twice. Earth's climate collapsed into chaos, just like today. What broke the climate back then? Is it breaking again now? And here's the critical question. If Earth recovered before, how did it do it? Because that knowledge might be the key to protecting what stability we have left. This is a story about the science of unpredictability and the people working to keep Earth rhythms steady. I'm Dr. Sylvia Pineda-Munoz, and this is Climate Itch. The weather doesn't just feel warmer anymore. It feels wrong. Floods strike where rain used to be rare. Pakistan records monsoon. Libya's deadly flash floods. Droughts linger in places once green. Kenya's farmlands, Spain shrinking reservoirs. Even the most advanced climate models sometimes miss what's coming next. So why is the planet's behavior becoming harder to forecast? Under normal conditions, Earth's climate has a rhythm. The planet's orbit around the sun shifts slightly over tens of thousands of years, changing how sunlight hits different parts of the globe. These orbital cycles guide the timing of ice ages and warm periods. When the system is stable, they explain almost everything. They're called the Milankovitch cycles. And for most of Earth histories, they've been the conductor keeping climate in time. But here's the problem. According to these cycles, Earth should be cooling right now, slowly drifting towards the next ice age. Instead, it's heating up faster than almost at any time in the geological record. Something is drowning out the rhythm. To understand what's happening today, scientists look hundreds of millions of years into our planet's past. A new study in Nature Communication by Dr. Ran Wei and colleagues at the Peking University reveals that between 360 and 250 million years ago, Earth went through two major bursts of tectonic and volcanic activity that threw its climate off balance. During both episodes, volcanic carbon dioxide surged into the atmosphere. Sea levels rose and fell unpredictably, and the regular orbital cycles that normally govern the planet's climate became blurred and chaotic. The first pulse hit between 360 and 330 million years ago. Earth crust became restless. Volcanoes erupted across the globe. Oceans widened, and with every eruption, carbon dioxide flooded the atmosphere. The planet started trapping heat. Climate patterns that had held steady for millions of years began to fluctuate widely. Ice sheets expanded and melted in uneven bursts. When geologists look at rocks from this period, they see irregular layers, the signature of a climate that had lost its rhythm. Then, something remarkable happened. For 50 million years, Earth found calm. Between 330 and 280 million years ago, the volcanoes quieted. Carbon dioxide levels dropped to some of the lowest in Earth history. The planet cooled into a long, stable ice age, and life exploded. When geologists examine rocks from this time, they see the regular beat of an orbital cycles repeating, steady layers that record glaciers advancing and retreating over predictable cycles. Forests spread across the tropics, capturing vast amounts of carbon. The forests that spread during that calm period captured so much carbon that they eventually became coal. The same coal that we're burning today. We're releasing the calm period back into the atmosphere. But the quiet didn't last. Around 280 million years ago, the crust woke up again. Volcanoes returned, ocean ridges expanded, and carbon dioxide surged back into the atmosphere. and the chaos returned with it. This second pulse of instability eventually set the stage for the dramatic warming that ended the Permian period, the biggest mass extinction in the planet's history. A reminder of how fragile balance becomes when the carbon cycle spins out of control. Together, these two pulses revealed a critical pattern. When carbon from within Earth overwhelmed the atmosphere, the planet's climate became unstable. When that carbon flow slowed, stability returned. In other words, Earth orbit controls when climate shifts happens, but carbon levels control how intense and predictable they become. That same pattern helps explain why our climate feels so unpredictable today. The orbit hasn't changed, but something else has. By burning the fossil fuels formed during that calm Paleozoic interval, we've become a new carbon force, releasing greenhouse gases as fast as some of Earth's biggest volcanic events. This rapid shift could explain why modern climate models sometimes struggle to predict sudden droughts, floods, or temperature extremes. When carbon levels soar, the feedbacks that govern Earth's system start interacting in unpredictable ways. The same way volcanoes once drowned out the orbit's quiet rhythm, our emissions are now introducing a new kind of noise. The result isn't just warming, it's a less predictable climate. But the past also offers hope. When tectonic chaos decreased, Earth recovered. Forests, oceans, and time itself help the planet find its rhythm again. And that's the same process many people are working to accelerate today. In Iceland, engineers are turning carbon dioxide into stone under ancient lava flows. In Kenya, reforestation projects are cooling local climates and restoring rainfall patterns. In the Philippines and coastal areas around the world, communities are reviving mangroves that buffer storms and store carbon deep in the roots. Around the world, scientists are combining data on Earth's orbit, carbon, and ecosystems to better predict and prevent climate change from accelerating out of control. And individuals play a role too. Every choice that lowers carbon, from switching to clean energy and protecting forests to reducing waste and supporting conservation efforts, helps quiet the noise and bring the planet's rhythm a little closer to balance. Understanding Earth's deep past reminds us that climate chaos isn't random. It follows a pattern. When carbon rises too fast, stability breaks. When it falls, balance returns. The difference now is that we understand what's causing the instability and we have the power to change it. At Climate Ages, we believe that when we understand, we care. And when we care, we protect. The late Paleozoic's two pulses of instability are recorded in stone. Ours is happening now. But stability can return if we act together to bring the planet back into balance. Subscribe for more science that explains our past and shapes our future. Did you know that Climate Ages started as a science storytelling newsletter that now has over 12,000 subscribers? Visit climateages.com and join a community of optimistic changemakers. I can't wait to see you there.